All right, let's use the normal distribution to compute a value for a random variable given the probability. All right, so let's start here with example one. A popcorn factory produces 20-ounce bags of popcorn. After a day of production, a sample of bags are tested and found the average to be 20.4 ounces with a standard deviation of 0.85 ounces. Find the highest value of a bag of popcorn such that all weights less than this represent the lower 80% of the distribution. Now, I'm a visual learner. So when I see this, I kind of want to think about what am I dealing with, right? What does this tell me? So I'm first going to draw a little picture, right? Thinking about if I just have myself a normal distribution and 80% less. So 50% is in the middle. So 80% is going to be over here. So I'm looking at, I want this value that represents, so it's going to be all over this, right? What is this value? So I know that my probability is 80%. Okay, great. What else do we know? Well, the mean is 20.4. The standard deviation is 0.85. This is all important information because now we say, okay, we want to find that value. Well, we can do that by finding the norm inverse, right? Because when you've used the normal distribution, you're usually trying to find probability, but we already have the probability. So we're working backwards. And if you think about the opposite functions, they're called inverses. So that's why I'm going to do the inverse. We're going to do the opposite thing. Now you can see it highlights what you need. So my first thing is I need my probability. So I can just click over here on B6. Then I need my mean. Then I need my standard deviation. This is why I like to put the data that I have in Excel. Makes it a lot easier to use cell references. I close my parentheses and I can see my value is 21.11. That means if my bags of popcorn have 21.1 ounces in it, it's going to be more than 80% of the distribution. Okay, and that kind of makes sense because if our average was 20.4 and standard deviation was 0.85, if you add 0.4 plus 0.85, let's just do that, 20.4 plus 0.85, we get 21.25. That's just one standard deviation away. So that really does make sense with us of 21.1 being a mathematical piece here. All right, let's do another example. This year's basketball team has averaged 82 points per game with a standard deviation of 8.6 points. Their goal is to always score better than 65% of the distribution. Find a score that represents higher than, that should say 65%. Let's just fix that real quick. Then 65% of their distribution. Okay, so again, I'm going to draw just a quick picture. So thinking about this, so we know, again, this is 50%. So 65 is going to be over here. And we're trying to find all of this. We're trying to find this value. Now, if their mean is 82, we know the value is going to have to be greater than 82. So again, what do we know? Well, we know the mean is 82. Not a percent, you goodness gracious. So our mean is just 82. Our standard deviation is 8.6. And one thing that I want to point out, you'll notice in the top middle or the drop down that I had, if you find that it's giving you a percent or it's giving you something you don't want, just go up there and change the way it's written out, and that's fine. The probability is going to be 65%. Okay, so again, I have the three pieces I need. So I'm ready to do the norm inverse. Start with my probability, then my mean, then my standard deviation, close my parentheses, and their score would be 85, right? We're talking about basketball. You have to just go. So 85 would be the highest, or to be their score to be higher than 65% of the distribution. And now let's do our third one. This year's basketball team has averaged 82 points a game, standard deviation 8.6. They want to focus on the middle 50%. That's where they want their scores to be. So what value does that represent? What values, excuse me. Okay, so again, let's think about this pictorially. So if I have, the middle 50 is going to be here. So we know that this inside is going to represent 50%. That means there's going to be 25 over here and 25 over here. So this value would be top 25. This value would be 25 plus 50. right? So for our probabilities, we're looking at two different probabilities here. We're looking at a probability of 25%. We're looking at a probability of 75%. Ooh, only 1% sign needed. Okay, now our mean, we still know that to be 82, not a percent. Why does it always want to be a percent? Okay, let's get rid of that. Let's make it an 82. And the standard deviation is 8.6. So now, because I'm trying to find the area in the middle, right, we're going to do the subtraction. We're going to do the first one. No, we just do them separately. Sorry, we're not trying to find the area. My apologies. We already have the probability. So we're going to do the inverse norm twice. Okay. So first we're going to do it for the 25. So 25, comma, mean, comma, standard deviation. So this value on the left, where's my drawing tool? This value over here is going to be 76. So that's the low end of the points that they would be willing to do. And then the high end, normal distribution, 75% mean, standard deviation. And we're looking at a high end value of 80. Well, let's round to 88. So we're saying if they would score somewhere between 76 and 88 points, they're going to be in the middle 50% of their distribution. And that's where they want to be. They know they're not always going to be up to their average, but this is where they're going to be happiest. Hope that makes sense in playing with the normal distribution to compute for a value, not always finding probabilities.